Hello, I'm John Stapleton with CodeVA, and this is a tutorial on reading, writing, and tracing arithmetic expressions with the material computer. Now, a material computer is an imaginary computer that we manipulate using this piece of paper and some objects, some manipulatives, and we're going to talk about how the material computer manages to do math. So consider this line of code. This line of code is directing the computer to output something. So the computer is going to try to put some value here, and then we'll write it down in our little piece of paper here to record the output. But there's a problem. This is not a data value. This is not a value the computer can print. Instead, this is a arithmetic expression. And the way the computer, most computers work, and most programming languages, and the way that our material computer works, is that when it encounters an expression like this, it's going to resolve it. And we can do that in sort of a slow way here, step by step. So let me grab some data here. We have an arithmetic expression, so we're going to jump up here to the math zone, and we'll create our two operands. So there's a value of 5 in this first operand, and a value of 2 in this operand. And our operation is addition. So addition, as you know, we have to find the sum of these two values. And to do that, we just kind of pull them all over here. And this is our result. And we'll, now that the material computer has found the result, we can place those values in output, count how many they are, that's 7. And then because these aren't stored in a variable or anything, the computer cannot keep them in memory. It will just discard them. So that's arithmetic expressions, right? The computer is going to, whenever it encounters an expression like that one, it'll figure out what the answer is and then output whatever the result. And there's lots of different operations you can use. If we had done that one, then the computer would have outputted to the value of 10. If we did division, and output a different value, we'll talk about that in a second, etc. Now, the thing that is interesting about the computer is that it can also output an expression with variables as one of the operands. So I'm going to go and trace through this program here. Let's do 3. So the first instruction in this program is to create a variable called a. So here's my variable called a, and I need to assign it a value of 3. So I'll grab 3 tokens and throw it in the container. That's how the computer does variables. There we go. Line 1 complete. Now, line 2, the computer needs to find the result of this expression, which is 5. So I'll grab 5 tokens for one of my operands. 5 tokens. Grab my little plus sign. Plus the value of a. Now, in order to figure out what the actual result is here, the computer needs to peek inside a. And I already know that a has 3 tokens because I just did that. Computer will peek inside. So the result that we print is 8. And then after we record that result, go ahead and reassemble my a variable, and then discard the data that's not stored in a variable, because the computer can't keep track of that. Great. That's how you do expressions with operands. You could even do an expression with 2 operands if you wanted to. That's totally fine. B plus a. We could do b times a, etc. Now a couple of other things that maybe will trip people up. First, if we did something like that, we had the computer print the results of this expression. you need to figure out which operation should come first. Should the computer resolve this part of the expression first, or should it resolve this part of the expression first? Luckily, the computer follows the order of operations that you may be familiar with from your math class. So it'll do multiplication before it does subtraction. So the result here will be 2, which is the value in the variable b, times 3, which is the value in the variable in a, which resolves to 6, minus 3, which is 3. So we would print a value 3. The computer would print the value 3 after this sequence of code. That's that order of operations. Now, you may also be wondering to yourself, what if we needed to divide integers? Let's make this a little bit more interesting. We'll say c equals a divided by 2. And we'll make a equal to 4 for now. Okay. Let's make this a little bit more complicated. We'll have the computer print the value of c. This will require me to make another variable. So let me get my arts and crafts supplies, make another label for the computer. And get all ready here. Okay, excellent. So let's trace this code. So we'll start our code by giving the variable a value of 4. So that's 4 tokens. Then we need to create another variable with the value c, with the name c, and the value equal to a divided by 2. Now a is 4 tokens. We just did that. So c should get 4 divided by 2, which is 2. And now we have 2 variables. And then we'll print c, which we just looked at it. It's 2. I don't even have to look inside. But if I wanted to, I could, right? That's 2. Now what if instead of 4, a was an odd number, like 5? What would the computer do with this? Well, the quote real answer of 5 divided by 2 is of course 2.5. But 2.5 can't fit into the variable called c because c is an integer. So that won't work, sadly. C can only store integer values because its data type is int. So when we do 5 divided by 2, the computer is going to do an operation called integer division, which is just to say that instead of finding 2.5, it will do the operation and then drop the decimal. So actually, in this situation, 5 divided by 2 is 2. Print the value 2. If you do this with like physical manipulatives, it makes a little bit more sense. So here's A, here's C. Now, what division is this, you have to find how many times 2 goes into 5. Now, so to do that, we can just like have 2 over here, and we'll just take 2 away until we run out. So 1, 2. Now I can't do it anymore. That's integer division. We drop the remainder, and our result is 2. 2 groups of 2. That's integer division. So this is something that's kind of tricky for people who expect the computer to be perfect at math. It's not, because it is governed by data types. Now, if you wanted to have the computer do this correctly, what you might do is say, let's just make a float value. Make a float value. We'll divide a by 2, and c will also be a float, because the data type float it allows the computer to store a decimal. That would work just fine for us. This this equation would be okay. To do floats, we won't use tokens because you can't have like decimal tokens. So I like to represent floats using just like written down. So we have 5 in A. We'll have 2 in C. 2. Stick that in there. And then to do our operation, or rather, C won't have 2 because we need to find the result of our operation. So 5 divided by 2. And then we're doing integer division here. 5 divided by 2 is in fact 2. So I'll just reuse that one. Throw it in C. 5 goes back into A. And then we print C, which is a value of 2. Oh, I just did integer division. I'm so sorry. We have to do floats. So I need a new little square. C would actually have a value of 2.5. Let's just add a 0.5 here sneakily. There we go. C is 2.5. No problem. My piece of paper can represent the value 2.5 very well, and we do output. So doing this operation with float values is totally fine because floats can do decimals. Now, something to know about data types, and this is sort of weird, is you can only perform operations, arithmetic operations, with values that are the same data type. So right now I'm doing a float and a float. But if, and just to make this more explicit, let's create a B integer, and we'll just use more random values here. So because B and A are both floats, this is totally fine. But if A were an integer, this would cause problems. The computer can't perform operations on variables that are 2 different data types. Because when you're doing division, if one is an integer and one is a float, it's unclear which type of division should you do. Should you do float division, where like normal division, or should you do integer division? It's not super clear one way or another. So in order to make this work, because certainly you would want to do, division with some integer values sometimes, is you can have the computer convert the integer variable into a float value, like so. This is called casting, when you convert the one data type to another data type. When you convert from a small data type to a larger data type, or from like an integer to a float, or integer to a double, you won't lose any information because float values can also be integer. Like you can have 5.0 as a float value. However, if you're converting from a float to an integer, the computer is going to chop off that extra information, just like with integer division. So it's something to be aware of. If I'm actually doing this as int C, and so if I were doing if I wanted to get an integer out of this operation, I would need to convert B to an integer. This expression, int B, will be equal to a value of 2 because 2.4 is float, and we can't represent a float as an integer. So we're going to get to the integer value below it. It's just going to chop off that extra information. It would even do that if it were 2.9. It's not going to round it. It'll just chop off the extra data. So that's a little complicated. Common problems with integer division and such. In casting between data types. There's one other pattern that with expressions that is useful to know. So let's create a new variable. We'll call this A, and we'll give it 1. Let me clear off my data here. And we're going to start over on my console. The variable A is getting the value 1. Now, then this next line of code can be a little bit like mind-boggling for people. If a math person looked at that line, they would say, no, it doesn't. A is not the same as a plus 1. A does not equal a plus 1. But we're not comparing these two values. Right now what we're doing is we're going to assign the variable a new value. So I'm going to trace through this real quick because the order you do things in can be a little bit confusing to make this work. And then actually we'll at the end, just for good measure, we'll print the variable a. So first, new variable called a. It gets a value of 1. That's line 1 down. Line 2, we're going to reassign the value a. And the value we're going to assign the variable a to is equal to this expression. Now to get this expression, we need to do a plus 1. 1 plus 1 equals 2. And then this value goes in to a. In this process, we have lost the old a value and given it a new value, a plus 1. This is called incrementing because the value in our variable has gone up by 1 here. So this pattern, a gets assigned a plus 1, is a pretty common but maybe slightly confusing way of expressing this like incrementing process. And then finally at the end, we need to output a, which right now is 2. We're back. So that's incrementing. That's everything you could possibly need to know about expressions. There are a lot of different operations available to people in computing. These are all the main arithmetic operations laid out here. And it's just important to kind of know the definitions for all of them. Definitely check out the text tutorial for detailed explanations on all these. And otherwise, good luck and happy coding.